Hello everyone, welcome back to uLearn Education Online channel. In the previous video, we have seen what is modulation and why the modulation is necessary in the communication system. Now, in today's video, we are going to see what is the definition of demodulation and also what is a baseband signal and what is a passband signal. Now, let us see what is a demodulation. Here, this demodulation is nothing but the opposite of modulation. Now, at the transmitter end, we have modulated the baseband signal, nothing but the information signal we have modulated, which means the low frequency information signal is converted to a high frequency information signal. That is nothing but indirectly the modulation process. Whereas here, what the demodulation will do? At the receiver end, the demodulation process will be done. What the receiver will do? Simply it receives the transmitted modulated signal and then it will process the received modulated signal, which in turn recovers the original information signal. The whole process of receiving the modulated signal and regenerating or recovering the message signal, that process we are calling it as a demodulation. So we can say that the demodulation is nothing but the opposite process of modulation. Now let us see what is the definition of a baseband signal. Here, these baseband signals are nothing but the signals that are generated from the information source. Okay, so that signals we are calling it as a baseband signals. We can consider the examples of baseband signals or audio signal, video signal, okay, or a sound signals, etc. So here these baseband signals are transmitted directly without any modulation. If you consider the audio signal frequency range, it is order of 0 to 20 kHz, whereas the video signal frequency range is 0 to 55 MHz. Therefore, we can say that the baseband signals are nothing but the signals that are generated from the information sources, or the unmodulated and the demodulated signals are called as baseband signals. These are the original signals that are generated from the information source, but these signals will not transmit directly through a wireless channel because of certain problems. So for this we have to modulate the signals. So next parameter is what is passband signal. Here we know that the baseband signals are not directly transmitted through a channel, and that too if you are considered a wireless channel. So in order to transmit the baseband signals through a wireless channel, we have to convert the baseband signals to passband signals. Now what is the conversion? Here these passband signals are a high frequency signals. Okay, now what we have to do? We have to convert the baseband signal, which is a low frequency signal, to high frequency signal. So the shifting or conversion of low frequency to high frequency signal process, we are calling it as a modulation process. So therefore we can say that the signals that are generated from the modulation process are called passband signals. Here the signals are transmitted with modulation. So if you consider the examples, then it is amplitude modulation, frequency modulation and phase modulation. And if you consider the practical example, then I can consider it as a satellite communication or satellite signals. Now let us see the basic frequency ranges. That is, AM frequency range is 550 kHz to 1650 kHz, whereas the FM frequency range is 88 MHz to 108 MHz. So finally we can say that the passband signals are nothing but the modulated signals. So in brief, if you observe, the baseband signals are the signals that are originally generated from the information source, or we can say that the unmodulated signal or a demodulated signal, we can call it as a baseband signal. Whereas the passband signal is the signals that are generated from the modulation process, we are calling it as a passband signal. In other words, we can say that all modulated signals are called as passband signals. So these are the three important definitions that kept in mind while discussing the uLearn communication course. Thank you so much for watching this video.